Hi everyone, this is Riham Tulan. I'm a senior technical animator on the MetaHumans project at Epic Games, and in this presentation we will dive a little bit deeper into the MetaHuman rigs in both Maya and Unreal Engine, some of our common workflows and ways you can customize the rig, and also some of the challenges and solutions we developed for this project. You can get our MetaHumans through the MetaHuman Creator app. If you haven't checked it out already, the MetaHuman Creator is a cloud-streamed app that allows anyone to create high-fidelity digital characters, fully rigged and ready with hair and clothing in just a few minutes. We have near infinite facial feature variations, 18 body types, more than 20 grooms, including facial hair variations. We have, at the time of this recording, 10 clothing assets, and all of these assets have several lots except for a few hair grooms, and those are highlighted on the app. We also provide in-engine animation rigs for both the face and the body, so you can animate directly right away in Unreal Engine. All what you need to do is fill out the early access form and create a Quixel Bridge account. All of the MetaHumans you create on the app will be later available to you on Quixel Bridge for exporting and for downloading and exporting to both Maya and Unreal. To export your MetaHumans to Maya, I recommend you change your rendering engine to DirectX. This is how you can see our textures right away in Maya and also the animated wrinkle maps. This step also requires you to restart Maya, so it may be better to get that out of the way before starting the exporter process. In Quixel, make sure that you have the latest plugins for Unreal Engine and Maya, so you have the latest from us. After that, you can select your MetaHuman, and in the download settings, make sure that you have both UAssets and source assets selected. Also make sure that your export target is set to Maya in this case. Once you download your MetaHuman, it will be available for exporting, and it will export to your Open Maya session. I would like as well to point out that when you download the Quixel Maya plugin, Quixel also installs a Quixel mod in your Maya modules folder, which takes care of all of the plugins and the scripts we need for the MetaHumans to work properly in the scene. When you export your MetaHuman to Maya, you will see that we have three skeletons: the driver skeleton, the body skeleton, and the head skeleton. The driver skeleton drives the body skeleton, which drives the head skeleton. The relationship between the head and the body stays true also in engine. The body skeleton drives the head skeleton up till the head joint. Then all of the face joints are driven, and the blend shapes also are driven by the rig logic node. The driver skeleton only exists in Maya for rigging purposes. For example, we use it to drive the twist bones and also drive the corrective poses. We will also discuss later how you can use the driver skeleton to create your own Maya animation control rig. All of our body deformations are joint-based deformations. We have 128 deforming joints, 150 joints in total. Of course, this number goes down with the lots. And if you would like to take a look at the exact joints we use for every lot, I would recommend either looking at the skin cluster or also checking out the MetaHuman lot data asset in Unreal Engine. We have a procedure rig to drive the twist joints, which is a standard step that you do in Maya to make sure that you get the correct twist values and to avoid any Euler gimbal issues. All of our leaf joints are driven by Unreal Engine RBF solver. RBF stands for radial basis function, which allows you to use any number of driver values to blend smoothly between any number of target values from any number of poses. And it's really a great way to drive any complex corrective poses or blend shapes. In this case, we are using poses because it's all joint driven. We have 14 pose drivers, 58 driven joints, and 104 poses in total. All of these poses are exported as animation sequences, which we create pose assets from. Pose asset is a traditional animation that consists of a series of keyframed poses. This example highlights the corrective poses we have for the calf. These poses are these pose assets are driven with pose drivers in the animation blueprint, which uses the RBF parameters to interpolate between the driven values based on the orientation of a target bone. In this case, this is the calf pose driver. As you can see in the image, we have the pose targets, which are imported from the pose asset. They match exactly. And we have also the RBF parameters. This setup lives currently in the post-process animation blueprint on the bodies. As I have mentioned before, the driver skeleton doesn't exist in Unreal Engine, so we process the skeleton as it is to the control rig, the deformation control rig. And this control rig is vastly different from the control rig that you may have seen out there animated in Sequencer. This control rig only lives under the hood to mimic the behavior of the deformation rig we have in Maya. Then we pass that to the pose driver, which drive the pose assets based on the RBF parameters. We get this question a lot, how you can create your own Maya control rig. It's quite simple process. All what you need to do is just use the main frame of the driver skeleton. As you can see in the video, I am hiding all of the leaf joints. Any joint that has corrective in it or twist in it, I'm hiding it. Then you will be able to see the main frame of the skeleton. And it's really great because we are already taking care of the more complex logic, like, for example, driving the twist joints and driving the correctives with our RBF plugin. So in a way, the driver skeleton is your control rig. I ran here a quick script to create control curves. So the animators are happier because no animator would like to animate the joints. You should be able to see the deformation exactly the same. If you have any problems, then just make sure that you haven't disconnected any of the connections that we have on the leaf joints or the twist bones. Exporting the animations from Maya. Here I have the ROM, and we will use the body joint set to export the animation. It's really great. Every time I look at this ROM, I remember how awesome Vojislav Pavakov, our lead rigger, did on these deformations. There's a lot of love that went to these rigs. In the outliner, you should see a body joint set. I will select all of the joints. There, you can also right mouse click and just select members. And I will use a game exporter to create a clip and export. Make sure that I have bake animation on to bake the animation non-destructively. Uncheck embed media or input connections. And export. In Engine, we will import the animation Traditionally, it will take just a minute to show the import options dialog. In the skeleton, make sure that you select the MetaHuman base skeleton. We have 18 body types and they are different in proportions, but they are all inherited from the MetaHuman base skeleton. You will see here a genes, but you can choose a preview mesh for that. So I dive into the folder structure to get the body type that I have exported with my MetaHuman. Look for it in the preview mesh drop-down menu, and you should be able to find it. And make sure that you click on apply to asset because Maya wouldn't save this preview mesh when you save the animation. As you can see here, the animation is floating, the legs are floating, and it doesn't look exactly as we had in Maya. This is because we need to tell the engine which skeleton we exported this animation from. So I choose as well the body type that I exported my MetaHuman from, and everything should match. In my sequence, I import the skeletal animation. And as you can see here, the genes is still the preview, is a preview asset because I forgot to click on apply asset before I save the animation. But it works as intended and Farah is looking great. The Fishboard has a different workflow in the sense that we export the animation from the control board curves directly. This is different, for example, from the body because on the body we export from the skeleton. This is possible on the Fishboard because the Fishboard in Maya is one-to-one with what we have in Unreal Engine. So the animation curves apply directly to the board. Similar to the body, we will just select the face controls set. You select the members and use the game exporter as well to export. I have had a clip created already, the face anim. Just make sure that I use the up and uncheck the embed media, export as ASCII and export. In Sequencer, I import ControlRig FBX. And in the import options, I just would like to highlight also an additional option. If you have any misspace, make sure that you replace it in the find and replace strings. This way it can map correctly to the control rig in Engine. And also change the channel mappings floats to translate Y. And you will see the same result that you have in Maya. In engine animation rigs, as you probably saw, we have two control rigs, the body control rig and the face board. We have one body control rig that we shared for the 18 body types, and this is thanks to the setup graph, which allows us to initialize the control transforms from the skeleton. This is an example of the setup graph for the clavicle, and as you see, I am getting the initial transform from the clavicle bone and setting my clavicle control offset from that. This is completely up to you. For example, you could use one bone to set the translation and another one to set the rotation. It is completely up to you how you would like to initialize your control rig. In this video, I demonstrate how we are using the same control rig, the MetaHuman control rig, for the different 4 body types that we are seeing in the level now. This is an amazing feature of Control Rig and of course a huge time saver for any production. And as you see, the rig is functioning properly on the different body types. Uh, we also have the ability to invert the animation from the skeleton to the control rig. And this is thanks to the backward solve event, and we refer to that process as the rig inversion. This is an example also on the clavicle where we are getting the transformer from the bone this time, the clavicle joint, and driving the clavicle control with that. And this time is different because these are not the initial transforms in this case. This is an example of our ROM animation, which is exported from the skeletal and getting retargeted on the control rig. This is a video we have released a couple of months back, and I highly recommend for more in-depth knowledge of how to animate the metahumans in Sequencer. You can also see how you can create multiple control rigs and just bake and invert on one to another, because we are baking on the skeleton. We are not baking on the controls themselves. We are baking on the skeleton, so we can keep using rig inversion to retarget to other control rigs. With the Faceboard, the rig sharing logic is completely encapsulated in the rig logic node, which is a compiled plugin, and the life work of Trilateral. It's really awesome to see how they change the industry and how the industry looks at real-time rigging in general. We don't really provide a way to edit the expressions of the metahumans. However, you can manipulate the interface and create even different variations of the interface. So the logic goes as follows. We have an interface, which is a board in this case, which drives the input curves of the rig logic, which drives the facial expressions. The facial expressions are joints and the blend shapes. When you animate, you bake back to the input curves, which through rig inversion, you can retarget on the same interface or a different interface. This concept is also very powerful because, as I mentioned, similar to the bodies, except that now we are operating on the input curves, you can create different rigs and retarget from one rig to another. To demonstrate the rig sharing aspect of the face rig, we will use the same animation that we have exported from Maya before and apply to the 4 head rigs that we see in the level. Follow the same process. Make sure that we map the float from translate X to translate Y and import. I will do the same for the 4 face rigs, so this process is sped up a little bit. As you can see, I hope it shows in the video, the face animation is playing on the 4 heads using the same rig, the MetaHuman Faceboard. all of these heads are playing their own individual expressions. We are just driving the input curves, which drive those individual expressions through the rig logic node. As I mentioned, because we are driving the curves, you can create any kind of variations, any kind and any number of variations for the face rig. Here, I have created on face control rig that drives the input curves, which triggers the expressions. You can really customize the rigs however you want, and you can create the variations that works better maybe for your production. Because we are baking on the curves, we can invert back animation from one rig to another. And in this case, the animation is running on the face board, and we will bake it to the curves. We'll save the animation. Now I will delete the face board because we baked to the input curves, so we don't need the board anymore. And when you import the animation back, you will see it is triggering the expressions properly. Now we will invert that to the on-face control rig. And as you see, we have the same result. We have the same animation, just running on a different interface. And it should still behave properly. So really there could be unlimited variations. You could, for example, create a very simple rig if you are working on previs or something and you would like to trigger very fast, simple expressions. And with the rig inversion and how you configure it, you can then bake back to the face board for more complex animation breakdown. Frequently asked questions, modifying the meta-humans. Can you modify the face shapes in the rig? We highly discourage you trying to edit the face shapes and trying to re-import back to Unreal Engine. This process can be quite destructive to the rig that you have, and we don't really provide or support a way for you to do that. Can you edit the body skeleton and re-import to Unreal Engine? Yes, for example, you can add extra joints if you would like to. However, just be aware that these changes will be propagated to the MetaHuman base skeleton, which consequently will also be propagated to any other MetaHumans you may have in the project. Unless, of course, you import the skeleton as a different skeleton. In this case. Can you edit the body mesh or skinning and re-import to Unreal Engine? Yes, you can do that. Just make sure that there are no gaps between the head and the body, and that should be fine. Challenges. So we've had quite a few challenges on this project. It's quite ambitious, and I hope it is quite apparent the quality we have shipped our MetaHumans with. We are blending between a massive database of scans, so the necklines have been a challenge to make sure that they stay intact on any of the body types you choose for your face. We have 18 body types, 4 lots each, that's 72 assets. With AAA quality deformations, it is easy to think about the initial cost for creating these rigs. and forget about the cost of updates and the technical debt it will create later, for example, for clothing, in-engine control rigs, and animations. These are examples of the production tools we developed and I believe could be useful for any production. We have the Pose Wrangler Maya Unreal Engine RPF user interface, which allowed us to create the RPF poses in Maya, and it is also one-to-one with what we have in Engine. This tool is available for free for the community. We distribute the Maya Unreal Engine plugin also through Quixel Bridge, and you can find it on Chris Evans, our lead technical animator, repository on Git, and also thanks to Jad Simentov for contributing to this great tool. Another great example of a production tool that Voyaslav Pavakov and Jad Simentov developed, the character pipeline tool. This manages, for example, all of the vertex IDs. We have decided early on that our bodies will have the same vertex IDs, and we also have had the neckline skin weights match one-to-one between all body types and also head rigs. This tool transfers the setup from a benchmark asset for a good head start and also handles our mesh and skeleton updates. The Pose Importer tool, and this is a great example of how you can use Python and editor utility widget in Unreal Engine to speed up your workflow. This tool handles re-importing all of the pose animations, updating all of the pose assets and the pose drivers in the animation blueprint, and many thanks for Jacob Buck for developing this tool. What we learned in this project is that the only constant in life is change. Invest in scalable pipelines and define your quality bar. Make sure that you have a benchmark asset that you can refer any member on the team to. Break down your dependencies. This is not a very easy task, and hindsight is 2020. Just to try your best to think ahead of all the other areas that it might be affected by your current task. Hope for the best and plan for the worst. Always create a buffer in case anything goes wrong. This slide has a few resources you can check out for starting with the MetaHumans in Unreal Engine. And I would like to thank the amazing team behind this product. This slide doesn't cover every member on the team, but I have to thank my technical animation team: Chris Evans, Vojislav Pavakov, Jared Monson, Jad Simentov, Kay Vasi, Nikola Visnich, Disney Nan, Jacob Buck, David Kral, and many thanks to James Golding and Lena Halper for helping the technical animation team on this project. Thank you so much, and we are all looking forward to your creations with our MetaHumans.